Good afternoon, viewers. You are welcome to another edition of this teaching from the King's tutorial. And this afternoon, what we'll be taking is using CRAMMER'S rule to solve 3x3 simultaneous linear equation. And we have an example on ground. The first example we are having here is using CRAMMER'S rule, solve the values of x, y, and z in the given linear equations. And we have the equations to be 3x plus 4y minus z equals 3. That's equation 1. Then the second one, x minus 3y plus 4z equals 1. That's equation 2. Then we have 2x plus y plus 5z equals 0. That's the equation 3. Now, to solve this now, we have to first transform this given equation to matrix form. So now, on transforming this equation, this is what we'll do. We all know the form and the shape of matrix. So instead of writing 3x plus 4y minus z equals to 3 and x minus 3y plus 4z equals to 1 and 2x plus y plus 5z equals to 0, then I rather write it this way. I write this one. I just write the coefficient of those variables, which I have 3, which is the coefficient of x for the first equation, 4, the coefficient of y for the first equation, and minus 1, the coefficient of z for the first equation. Then going to the second equation, the coefficient of x is 1, the coefficient of y is minus 3, and the coefficient of z is 4. Then for the third equation, the coefficient of x is 2, and the coefficient of y is 1, and the coefficient of z is 5. Now, this is it. We have this is signifying, is showing a 3x3 matrix. Then now I will now have it to be, then I will now have another bracket here now. Then I can now insert my variables, which is x, y, and z. And then I will now have the equality sign showing the answers in front of the equations. We have 3, 1, 0. Such that if you use what we have inside this bracket, that is x, y, and z, we use it to multiply this, we get this back. We get this equation back. Are you with me? So now, this now is now in form of a matrix now. And in solving this, all we need to do is, first we have to pick this value. Is in form of ax equals to b. So now, what we need to do, our 3x3 matrix here is representing A, and x, y, z is representing x, and 3, 1, 0 is representing 0. So now, the first thing we need to do after transforming it into matrix form is to find the determinant of A. And then, now I say determinant of A. And when we are finding determinant of A, we have to assign signs to the first row of the 3x3 matrix. And that is, you see, this is plus, this is minus, and this is plus. All together. So now we pick the first sign, which is plus 3. So you now say plus 3, then you have a 3x3, 2x2 matrix again, so that if you cover this row, the first row and the first column, you'll be left with minus 3, 4, 1, and 5. So you now write that. So you write that there. Then we go to the second sign, which is what? Minus. And the value we have there is 4. So we'll say this is minus 4. Then you draw another bracket, and we cover this is still the first row. Then we cover the second column. If you cover the second column, we have 1, 4, 2, and 5. So you now write that inside that bracket. 1, 4, 2, and 5. And for the third signs, we have plus, but we are having negative sign in front of the numbers that is there. So you just say plus times minus, which will give us minus at the end of the day. Now say minus 1. Then you draw that again. Then you cover the first row and you cover the third column. You will be left with 1, minus 3, 2, and 1. That is 1, minus 3, 2, and 1. So the next thing we have to do here is we multiply the rows here inside the 2x2 matrix. so that you have 5 times minus 3. That will give us minus 15 minus 1 times 4, which is 4. And mind you, when you are doing this multiplication, you have to go like this one first. If you are going this one first, you will be wrong. So you try this one first. That's why I'm saying 5 times minus 3, which is minus 15, then minus 1 times 4, which is 4. Then for the second one, I have 5 times 1 is what? 5. Minus 2 times 4 is what? 6. Then for the last one, we have minus 1 in bracket. 1 times 1 is what? 1. Minus 2 times minus 3, that will be what? Minus 6. And we now continue like that. Minus 5, minus 15, minus 4, that will give us what? That's minus 19. Then minus 4 into bracket, 5 minus 6, that is what? Minus 1. Then for the last one, minus 1. 1 minus minus 6. Here we have to be conscious of these two signs. So we have to say minus times minus, which is plus. So we have 1 plus 6, which is what? 7. So now, if we multiply 3 times minus 19, plus times negative will give us negative. So you have minus 57. Then minus 4 times minus 1, that's minus times minus, which is plus. Then you have plus 4. Then minus times plus 2, because 7 is positive there. That will be minus 7. So you now add it, minus 57 minus 7. That gives us minus 64. Minus 64 plus 4, that gives us minus 60. And that's the determinant for the 3 by 3 matrix, which is representing A. So now, what we need to do now, we've gotten our determinant for A. The next thing we need to do is we have to represent this column, the first column, that is 3, 1, and 2 that we have here. We have to represent it by, we replace it by what we have here, which is 3, 1, 0. And then we now look for the determinant of that, such that we have it to be, instead of now writing 1, 3, 1, 2, you now write 3, 1, 0. Then you now write the remaining values left here, right? So now what we need to do here is we look for the determinant of this. Mind you, we realize that this one is quite different from this one, because the values we have in the first column here is different from the value we have in here. So we solve this one actually using, we solve the determinant of this value. So we have, so now on solving that determinant, we will get minus 78. That will be the determinant for this. And now what you have to do again is just to divide this value by the determinant we get here. So you now have it to be x now. That will now give us x. You now have minus 78. That is the determinant of the new matrix we just solved, all over the determinant of A itself, which is minus 60. Which is minus 60. Minus cancel minus. Then we can now begin to cut. Now, if we now cut this, we first cut it by 2. We have 39 over 30, and then cutting 39 over 30 by 3, we now have our final answer to be 13 over 10, which you can say 1 whole number 3 over 10. So that's the value for x. Now the next thing we need to do is, you know, in the first place we have replaced the first column with what we have here. So we are done with the first column. We have to replace the second column too by what we have here. So in that we have, so now what we need to do then is find the determinant of this, but before doing that we assign the signs, which is plus, minus, plus, and then we now look for the determinant. So now on solving for the determinant of this, we have that answer to be 20. So what we need to do now, that we now have to get our y, we now have this determinant, that this new determinant, which is 20, over the determinant of A, which is what? Minus 60. And if you cut this, 20 in 20 we goes 1 time, then 20 in 60, that's 3. So we now have the answer to be minus 1 over 3. That's for y. So now we now go to the next column. We replace the next column here, which is minus 1, 4, and 5 by what we have here. So we have, so now this is what we have by replacing the third column by what we have here. So instead of writing minus 1, 4, 5, we write 3, 1, 0. And the next thing we need to do is find the determinant. So now on solving this, the determinant of this, we have our answer to be 26. So now that we now, to get our z now, z is 26 over the determinant of A, which is minus 60. Then we have z to be minus 13 over 30. So the process we have gone through is what we call is what we call CRAMMER'S rule, and we have used that to get the values of our x, y, and z. Our value for x is 13 over 10, or we call it to be 1 over 3 over 10. The values for y is minus 1 over 3, and the values for z is minus 13 over 30. Thank you. God bless you.